Welcome, class, to the Intro to Java Programming. This is the first of 3 lessons on looping statements. In this lesson, we will review the standard for loop along with a visual example, the syntax used, and some code examples. Time for a Coach Joe challenge question. Using the systemoutPrintln method to output a value, what code will print the numbers 1, 2, and 3 on separate lines? Interesting. This answer will work. Now, what if I need to output 20 numbers? Should we create 20 print line statements? That would be a fair amount of work to write those lines of code. What if I need 1,000? Often you will be in a situation where you need to execute a set of code multiple times until a specific condition is met. There are 4 types of looping statements that will accomplish this task. In this lesson, we will cover the standard for loop. Let's say we want to output the numbers 1, 2, and 3. We started with these 3 lines of code. Tell me something similar that all 3 lines have in common. Correct. They all call the same method. Now, tell me something that is different on all 3 lines. Correct. The output value in parentheses is the only thing that is different from each line. So, is there a way to make the number in parentheses the same for each line? Yes, if the numbers 1, 2, and 3 were a single variable, we could reduce these 3 lines down to 1 line of code. With this new variable, we'll need to know a few requirements. What is the beginning value? Correct. 1 is the beginning value. What is the ending value? Correct. 3 is the ending value. By what value will we increment this variable after each print line statement is executed? Yes, we should increment the variable by 1. Before we continue, I would like to point out Coach Joe rule number 32. The use of the standard for loop may be an indication of poorly designed code. It is acceptable to use the standard for loop when you know exactly how many times you need to execute a block of code, or if you're demonstrating a non-production idea. Don't use this for loop for collections. Let's look at the syntax for the standard for loop. The keyword for is used to start the statement. Inside parentheses are 3 key components to define the for statement. After the parentheses are curly braces used to hold the code block. Let's fill in the 3 key components. First, we create a data type and a variable name with an initial value. This can be any data type, but it is very common to declare an int since most loops will be counting the number of iterations. The variable I will be a counter value that can be used by the for loop. The variable I is a common name going back before the 1980s. You can use any variable name you choose. The initial value is the beginning value we defined in our requirements. A semicolon is used to end this command. The second component is a condition that, if true, will continue to execute the for loop code block. If the condition is false, the for loop is over. I less than or equal to 3 is the condition. The requirements has the ending value of 3. So, if I is less than or equal to 3, the result of the condition is true and the code block will be executed. Once the value is 4 or higher, the condition will be false, meaning the code block is not executed and the for loop will end. The semicolon is used to end this command. The third component is used to increment or decrement the for loop counter variable after the code block is executed. The requirements has the counter being incremented by 1. It is common to use a unary operator like I++ when incrementing by 1. You could also use an arithmetic operator like I equals I plus 1. Yes, with the proper initialization, condition, and decrement statement, you could also loop from 10 to 1. Inside the code block will be all the code to be executed for each iteration of the loop. Here is where the systemoutPrintln method is placed. The result of this for loop statement will output the numbers 1, 2, and 3. If the condition was changed to I less than or equal to 20, the statement will output the numbers 1 to 20. Inside the code block can be 0 to many lines of code. There will be a warning if you have 0 lines, so it is recommended to have at least 1 line of code. It is common to assign values, have an if statement, and call other methods. The code block can contain another for statement. This is called a nested for statement. Although I don't have a Coach Joe rule for nested for loops, I will offer this tip. Try to keep the code simple and the number of lines inside the for loop code block to be few. The for loop should not be too confusing. Let's look at a flowchart and see if this helps. The for loop starts with the for statement. The for loop variable is initialized. This variable is typically used to be some counter for the for loop. Remember, you are using a standard for loop because you know exactly how many times you intend to execute a code block. Here, the int variable I is declared and set to 1. A condition is defined. Here the condition is I less than or equal to 3 is defined. If the condition is false, we exit the for loop. If the condition is true, we execute the code block. After the code is executed, the for loop counter is updated. Here it is incremented by 1. The process repeats by checking the for loop condition for true or false. As you can see, as long as the condition is true, the code block will be executed. Time for another Coach Joe challenge question. Looking at this for loop statement, how many times will the code block be executed? The answer is 0. Take a look at the flowchart again. The for loop initializes a variable and sets the value to 4. The condition I less than or equal to 3 is tested. Since 4 is not less than or equal to 3, the false condition path is taken. The code block is never executed and the for loop ends. How about one more Coach Joe challenge question? Looking at this looping statement, I changed the condition from I less than or equal to 3 to I greater than or equal to 3. Do you see a problem with this statement? Correct. This is an infinite loop. The condition I greater than or equal to 3 will always be true. The loop has no way of producing a false condition and therefore will run forever. Use caution when creating loops. Make sure there is a way for the loop to exit. I would like to show you 2 more commands. Even though these commands are allowed, you should limit their use. The first is the break command. During the execution of the code block, you may decide the for loop should end. The break command will stop the for loop. There are situations when a break is a valid exit option. The other command is continue. During the execution of the code block, you may decide to stop processing code for this iteration of the loop. The continue command will exit the code block and proceed to the increment statement. If the condition is still true, the code block will be called again. The continue statement does allow code block execution options. However, it's an indication of poorly designed code. Without going into too many details now, the continue statement violates many Coach Joe rules that will be covered in future lessons. For now, see if you can find a way to avoid this statement. Let's go to our basics project in IntelliJ, close any open class tabs. Let's create a new package inside the Java folder. Let's call this loops. Inside the loops package, let's create a new class called forTest. Let's make a little space, import in this first test, import these classes. This test will output the numbers 1, 2, and 3. Here is the for statement. Int I is set to 1. Execute the code block if I is less than or equal to 3. Increment I by 1 after each code block execution. System out println will output the variable I. Let's run this test to see the output. Here are the numbers 1, 2, and 3. This test will count the number of code block executions. We declare a loop counter variable. Here is the for statement. Notice the increment can be I equals I plus 1. In the code block, the loop counter variable is incremented by 1. Let's run this test. And it passes. This test will count down from 10 to 1 and verify the code block was executed 10 times. We declare a loop counter variable. In the for statement, notice the variable I is decremented by 1. If we run this test, it passes. This test will show that a loop counter can be incremented by 3 instead of 1. The for statement will add 3 to the variable I. Here the value of I is outputted. Let's run this test. And it passes. Notice the values 1, 4, 7, and 10. This proves the loop incremented by 3. This test will show the break statement. Inside the code block, if the value of I is greater than or equal to 4, we will call the break statement and exit the for loop. Let's run this test. And it passes. Notice the values 1, 2, and 3 were outputted. The loop ended before printing the number 4. And this final test will show the continue statement. Inside the for statement, if I is a multiple of 3, we call the continue statement to exit the code block but not exit the for loop. Here the value of I is outputted. Let's run this test to see the output. Notice the numbers 3, 6, and 9 do not appear, but the other numbers from 1 to 10 do appear. The continue statement skipped the lines of code where the value of I was printed. Here's a summary of all the test code we wrote for this lesson. You should now have an understanding of the standard for loop, including the syntax and code examples. Use of the standard for loop is meant for those situations when you know the exact number of iterations a block of code will be executed. Remember, the for loop with the condition that is never false will execute the code block forever. Avoid infinite loops. Your optional homework assignment is to create a test that will add up all the numbers from 1 to 10. Use a for loop in your solution. In the next lesson, we'll discuss the enhanced for loop. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!